In this section, we are asked to rationalize the denominator. Rationalizing the denominator means that we have a radical in the denominator and we cannot leave it there. So we have to think of what can we multiply whatever radical is in the denominator. And if this is the square root of 6, I'm going to have the square root here. And I have to, if I look at my list, these are the numbers that we can square root. So what can I multiply by 6 such that it will equal one of these numbers here on this list? So I know that if I multiply 6 by 6, it will get me this number on my square root list. And whatever I do in the denominator, I'm also going to do in the numerator. So now we have 4 times the square root of 6, so 4 radical 6, over square root of 6 times square root of 6 is square root of 36, which now has been rationalized because now the radical is out of the denominator. Okay, then we need to look at the numbers that are outside the radical. So we have a 4 and a 6, and the 4 and the 6 can be simplified by 2. We can divide both of them by 2. So we get 2 radical 6 over 3. So to rationalize the denominator here, we're going to multiply and here's a list of some cube roots. We have to think of what can we multiply 4 by? What can we put here? What can we multiply 4 by so that it gets us one of these numbers that we can find the cube root of? So I know that if I pick this one, that 4 times 2 would get me 8. Okay, now the variable part. 3 can't go into 7. So I want to make it a number that 3 can go into. So 3 can't go into 7, 3 can't go into 8, but 3 does go into 9. That means we need 2 more x's because x to the 7th times x squared would make it so that it equals x to the 9th, and 3 can go into 9. So now that we know what to multiply by, we're going to also multiply it to the numerator. So now we have 3x squared times the cube root of 2x squared all over 4 times 2, that's the cube root of 8, and then x to the 7th times x squared is x to the 9th. So if we did this right, when we evaluate this, this should not be a radical anymore. So the cube root of 8 is 2, and 3 goes into 9 3 times. Okay, almost done. Then we need to look at what's on the outside here and see if that can be simplified. So since we have x's in the numerator and we have x's in the denominator, we're going to subtract the exponents. So we're going to take 2 minus 3. So 2 minus 3 is negative 1. That means there's going to be an x in the denominator. Okay, so to rationalize the denominator, since this is a 4th root, we need to think of what number can we multiply 2 by so that it gives us a number in this list here. These are numbers that we can take the 4th root of. Because the 4th root of 16, what number times itself 4 times is 16? That would be 2. And what number times itself 4 times is 81? That would be 3. So these are just 3 examples of numbers that you can take the 4th root of. So I know that 2 times 8 is 16. So that's how I know to put an 8 there. Then 4 can't go into 5. So 4 can't go into 5. 4 can't go into 6. 4 can't go into 7. But 4 can go into 8. So instead of being x to the 5th, I want to change it to x to the 8th. So if there's 5 here, I need 3 more. So that way when I multiply them, it would be x to the 8th. And then whatever I multiply the denominator, I'm also going to multiply the numerator. So 2 times 8 is 16, and x to the 5th times x cubed is x to the 8th. So the 4th root of 16 is 2, and 4 goes into 8 twice. And then if we take a look at the numerator here, and we take a look at what's outside the radical, and here we have to check if that can be simplified. So it cannot be simplified, so this would be our final answer. Okay, so to rationalize the denominator, since this is a cube root, I need to think of what can I multiply 9 by so that I can make it a number that I can cube root. So if we take a look at my list here, these are numbers that we can cube root. So I know that I could take 9 and multiply 9. So 9 times 3 would get me 27. So whatever I multiply the denominator, I also need to multiply to the numerator. So we have 2 times the cube root of 3 all over the cube root of 27. So if we did this right, this should no longer be a radical because the cube root of 27 is 3. Then when we're done, we're going to check what's on the outside and see if that can be simplified. So it cannot be simplified, so this is our final answer. Okay, to rationalize this denominator, we need to think about what we need to multiply 2 by so that we get a number here in our list. These are all numbers that we can cube root since this is a cube root of 2x. So I know that if we take 2 and multiply by 4, we would get 8. Then 3 cannot go into just x, just 1. So 3 cannot go into 1, 3 cannot go into 2, but 3 can go into 3. So I want it to be x cubed. So if I have x to the first power, I need 2 more. So in other words, when I take x to the x times x squared, it will give me what I want, x cubed. So whatever I multiply by the denominator, I also need to multiply to the numerator. And then in the denominator here, we get 2 times 4. 2 times 4 is 8. And x times x squared is x cubed. Now if we did this right, the denominator here should not have a radical anymore. So the cube root of 8 is 2. And then 3 goes into 3 once, so no radical left in the denominator. Then when we're done, we need to take a look at what's on the outside here and see if we can simplify it, which we can divide 6 by 2 and 2 by 2. So we would get our final answer, All right, in order to rationalize the denominator for this problem, we need to multiply by the conjugate. And the reason why that is because there is a difference here. There is two numbers here being subtracted. So we are going to multiply by the conjugate, which we keep the first number both the same. And then if this is a negative square root of 7, then we're going to put a positive square root of 7 here. And whatever we multiply the denominator, we multiply it in the numerator. So we have to multiply 3 by 5 and radical 7. So 3 times 5 is 15. And then 3 times radical 7 is 3 radical 7. Now we're going to do the same thing with the denominator. So since these are conjugates, these are both the same number and these are opposite, these are a difference of two squares. So instead of foiling this, which you can, instead we can do a shortcut. 5 times 5 is 25. And then negative radical 7 times square root of 7 is negative square root of 49, which the square root of 49 is 7. And then we have 25 minus 7, which is 18. So putting that all together, this is what we have in the numerator, this is what we have in the denominator. Now we have to check and see if anything can be simplified. So if we want to simplify this, because it has this plus sign, we can separate this as 15/18. And then we have that. And now we can divide this by 3. And we could divide this also by 3. And 3 divided by 3 is 1, but we don't have to put 1 in front of a variable or a radical. So we would get this as our answer. Or we could also write it as 5 plus radical 7. Since they have the same denominators, we could write it also like that.